Donovan, this is for you.
Anthony just threw the ball at a parabola of -1 divided by 24, parentheses x minus 12 close parentheses squared plus 6. If I can calculate exactly when the ball will reach me, I should be able to catch it perfectly. To find the velocity of the ball, I will need two x coordinates. I'll start by finding the middle of the parabola, which on this graph is also the maximum. I derive the parabola and get -x divided by 12 plus 1. This gives me the slope. Then I replace y with a 0 to represent the slope as it reaches its peak. Now I can manipulate the equation to get x by itself. This gives me a maximum of 12. It's been 1 second since Anthony threw the ball, and the ball has reached its halfway point. This means I have two x coordinates and times to go with them. I use this equation of average velocity and plug in both my x and my time value sets. After some calculations, I get an average velocity of 12 meters per second. Now all that's left is to find the total travel time of the ball. I use an equation where I can enter my velocity value and the distance between me and Anthony to find the time. I get 2 seconds of total travel time. Since 1 second has already passed, I'll subtract 1 and find that the ball will reach me in exactly 1 second.
If I throw the ball at parabola y equals -1/20 parentheses x minus 10 squared plus 5, the ball should reach a distance of 20 meters before it hits the ground. When I take the derivative of this function, I get the slope. Then I can plug in a 0 for y to find the absolute maximum. This gives me x equals 10. And since my bicep is 3 inches tall and 6 inches long, I can use the equation limit 0 to 6 -1/9 parentheses x minus 3 squared plus 3 dx to find out that my bicep has an area of 16 inches squared. This gives me more than enough power to make the throw.
It's perfect.
You're not as strong as you think you are.